In this video, I introduce learning from real-world free offline data. Planning with a latent dynamics model is a real-world free Markov decision process that learns latent dynamics using a reconstruction-free self-supervised learning objective and the joint embedding predictive architecture, as shown in here. This planning with a latent dynamics model. The encoder maps the current state and the goal state into the latent space. This is a predictor that is used to predict the future latent states. At a tester time, PLDM plans in the learned latent space to reach goals. Given a trajectory sequence from x0, a0 to s t minus 1, a t minus 1, PLDM model is defined as here and explained in this figure, where z caret t key is a latent state predicted by predictor key, and zt is the encoder output at step t. Training objective is to minimize the distance between predicted and encoded latency. Given target latent z and predicted latent z caret t, where h is the model horizon, n is the batch size, and d is the feature dimension. The similarity error between predictions and encodings over all time steps is computed by using this formulation. The indices are explained in this figure. To prevent a representation collapse, inverse dynamics model predicts the action between adjacent latent states. The overall objective to prevent collapse is defined as a weighted sum of 5 terms. The first term is a prediction error, as defined here. Second is a variation error that forces the embedding vectors of samples with a batch to be different. This is the covariation loss that used to prevent high correlation. And this is the time similarity error to smooth the temporal signal. And this is the inverse dynamic model error that is used to measure the action prediction error. PLDM is trained to find the optimal policy, namely a sequence of actions that gets the agent to approach the specified goal from any arbitrary start state. At the tester time, given the current observation S0, the goal observation SG, pre-trained encoder H theta, predictor alpha theta, and planning horizon H, the planning objective is defined as here. A, this is the optimal action. The planning procedure is defined as here, where G goal is a goal reaching objective. C uncertainty penalizes the model from choosing state action transitions that deviate from the training distribution, with gamma is between 0 and 1 as the temporal discount. PLDM replans every iteration with the environment. For more details, please check with these references. Thank you. Bye.